Millions of years ago, once upon a time in the distant past, our planet was a tropical paradise. On the territory of modern-day Georgia, Pataphyliosauropus roamed, hunted by megaraptorans, while the world was a single continent. Most of the land was occupied by giant creatures, the dinosaurs, and then they disappeared. Scientists called this event the Cretaceous-Paleogene extinction. In popular culture, it is known as the extinction of the dinosaurs, but what really happened? To figure this out, we need to go back 66 million years, to the time between the Cretaceous period and the Paleogene. In a very short period, 20% of all living creatures disappeared from Earth, including approximately 16% of marine animals and 18% of land animals. All of this is extremely bad, but 200 million years ago, the Earth experienced the Permian-Triassic extinction, which wiped out 60% of all living species from the planet. Everything started at the end of the 18th century with an unusually bold idea. Georges Cuvier hypothesized that species of living creatures could go extinct. Before that, it was believed that the planet, with all its animal and plant life, was unchanging and existed exactly as God had created it. Cuvier's idea was that he said, wait, then what about the Great Flood? Maybe things were different even before the flood. In the second half of the 18th century and the first half of the 20th century, it was accepted that dinosaurs gradually exited the evolutionary stage. Back then, during that period, they didn't talk about the extinction of dinosaurs as a single event. Scientists hadn't reached a consensus on what happened and how. Over the course of 100 years, many versions of evolutionary theory emerged. For example, it was hypothesized that dinosaurs went extinct because mammals ate their eggs. In short, there were as many versions circulating as there were scientists. There is also the latest version today. The temperature on Earth changed, and they were unable to adapt to the new conditions. For example, the dinosaur Argentinosaurus. The giant creature walked around during the day, eating. During this time, it was getting so warm. Let's keep in mind that the average temperature on Earth during this period was 25 degrees. And when our giant dinosaur would lie down on the ground at night to sleep, its body could not manage to cool down. With the sunrise, its body was warm, but as soon as the temperature dropped globally, the dinosaurs could no longer wake up. This happened because this specific dinosaur, and large dinosaurs in general, were neither warm-blooded nor cold-blooded. This state is called mesothermy, also known as gigantothermy. Now we return to 1977 in America. Scientist Luis Alvarez discovered a metal, a substance called iridium, in the rock formations at the boundary between the Mesozoic and Cenozoic eras. This metal is very rarely found on the Earth's surface. Finding it in such concentration in the deposits of two geological eras was an anomaly. What is interesting is that such a large amount of iridium had previously only been found in meteorites. A year later, in 1978, a Mexican oil company discovered a large geological anomaly in the east of the country on the Yucatan Peninsula. The structure, with a diameter of over 150 kilometers, covered the entire peninsula and extended far into the sea. The time of this anomaly's formation coincides exactly with the geological period when the unexplained excess of iridium was recorded. Everyone realized that a picture of a grandiose catastrophe had formed. Luis Alvarez's hypothesis received significant confirmation. Yes, as you have already realized, an asteroid struck the Earth, which left the Chicxulub crater. This refers back to the already mentioned impact crater located on the Yucatan Peninsula. It must be said that the matter did not end with just one asteroid. About 72 million years ago, a sharp drop in sea level began by almost 200 meters. The marine ecosystem found itself in a difficult situation. At the same time, the climate was changing. The average temperature on the planet back then was about 25 degrees, which is much higher than today's, but between 68 and 66 million years ago, it fluctuated, sometimes rising and sometimes falling. The temperature on Earth dropped by 10 degrees and almost immediately returned to its previous level. 500,000 years before the Cretaceous-Paleogene boundary, strong signs of volcanic activity appear. The Indian Peninsula became a continuous magnetic zone. Huge lava flows continued to erupt from cracks in the Earth's crust and spread over millions of square kilometers. At the same time, gases and ash were released into the atmosphere, which of course caused a volcanic winter. This was accompanied not only by cold weather but also by acid rain. The acidity of the ocean also changes. It is too early to talk about extinction, but ecosystems are suffering very severe and heavy damage. However, even after such a catastrophic crisis, it was possible for nature to recover. There was hope and nature was gathering its strength, but 66 million years ago, an asteroid killed that hope when it struck the Earth. According to research, the asteroid's diameter was more than 10 kilometers, and upon impact, it vaporized millions of tons of the Earth's crust and rocks, which then turned into ash and covered the entire planet in a thick layer. Huge tsunamis crash into the coastlines. The seismic waves generated by the comet's impact activate volcanoes all over the Earth, and in a matter of minutes, the planet turns from a tropical paradise into hell. With hot air, sulfuric acid rain, widespread fires everywhere, and eternal night. It would have been possible to survive this terrible catastrophe had it not been for the added problems with the sea. What I mean is that a combination of problems caused the extinction, and now let's figure out what the sea had to do with it. The foundation of marine ecosystems was phytoplankton. Although the share of these microscopic creatures in the total biomass is relatively small, they are the very foundation of all life in the ocean. Phytoplankton are eaten by zooplankton, which in turn are eaten by fish, jellyfish, mollusks, and many other creatures, which then feed predators, giant-shelled ammonites, and other massive predators. Before the comet struck Earth, microplankton had already been destroyed due to climate change, which caused the food chain to break. The situation on land was completely different. While sea dwellers were practically wiped out due to climate problems, land creatures were, on the contrary, stimulated. At the end of the Cretaceous period, flowering plants appeared, entering into complex symbiosis with the insects of that time. After the appearance of cereals and grasses, a grassy soil cover emerged for the first time. During the day, the Earth belonged to bloodthirsty giant reptiles, while at night it became a nest for numerous small mammals, which resulted in mammals occupying the lowest part of the food chain. Our ancestors, while the dinosaurs were the superior class, and when the asteroid hit the Earth changed then. The terrestrial catastrophe began with the destruction of plants. For several years after the asteroid impact, it was as dark during the day as it was at night. Naturally, of course, this caused the destruction of most plants. Herbivorous animals were immediately put in danger. First, the sauropods, the giant creatures, went extinct, and then, as a natural consequence, first the large and then the medium-sized predators disappeared from nature. Birds and mammals survived this catastrophe, but at what cost? 90% of their species were destroyed. A few decades after the asteroid impact, the Earth's surface had completely changed. The planet became cold, but it had begun to recover. First, the plants began to grow. Preserved seeds began to sprout after many years of darkness and cold. The organisms that survived began to reproduce. Among the successful ones, 3 groups stand out. First, the bony fish. Once, this was a rare and not so successful group of fish, but today we only know bony fish. They are the majority, having managed to reproduce and adapt to the ecosystem so well. Second, of course, and unsurprisingly, the mammals. Once these were small nocturnal animals living in the shadow of the dinosaurs. After the extinction of the dinosaurs, they found themselves at the pinnacle of the biological world. A boom in mammal diversity occurred, and all of this happened very quickly, just 100,000 years after the asteroid impact. And as you know, mammals are us. And now, the third group that survived this tragedy, the comet. You might be surprised, but I want to tell you the dinosaurs survived. One lineage which turned into today's birds and gained a huge advantage in the New World. The undeniable advantage of flight and their relatively small size not only saved the birds but also turned them into one of the most numerous groups of animals. Today more than 10,000 species of them are known. After the mass extinction, in just 1 million years, the Earth was full of life again, but it was a completely different world, with different conditions, a different climate, and different animals and fauna. And of course, without those giant reptiles that ruled the Earth a few million years ago. But now, before I finish, thank you very much for watching the video to the end. Let today's code word be Sataplia, and of course, thank you very much for the comments and likes you write. I'm glad to see you on my channel again, and see you later.